Hello everyone, it's May the 31st. Okay, so we are going to continue on what we left over yesterday. So we have the hard problem, which is quite interesting. But we didn't finish this one. We got a wrong answer. So I still don't want to give up on this idea yet. So I'm going to, of course, check this. Oh, I cannot check this, I just realized, because this one is too many rows. Okay, so, which means we probably shouldn't continue this route. It made sense to me, but apparently it's not accurate. So I think for this question, we are just going to call it and then see the hints. But we're going to hold off on this one. First off, today's challenge, and then we'll go there. So it's an easy one, so hopefully we can flatten it out in like maybe 10 minutes. Given an array, we define a running sum of an array as this equals sum, return the running sum of nums. So just a prefix sum. Yeah, just a prefix sum. Do you want to, as the tradition, we cannot give up on the tradition. Even though the problem is very simple, we still need to do this. Oh! So we're doing tomorrow, so it's going to be June. Wow. We're arriving at June. Okay. It's already June. Alright, so the problem itself is very simple. I think I'm going to do iter tool. Accumulate. That should suffice. Yeah. Okay, so we're not gonna even see this one. This one's done. Alright, so let's focus on this one. Let's see hint number 1. For some tile, how can we determine when, if ever, the file reaches? I have that, right? This is that. We can use multi-source BFS to find the earliest time the file reaches each cell, okay? Then, starting with a given t minutes of staying in the initial position, we can check if there is a safe path using the obtained information. That seems to be exactly the same as my solution. Oh man, that's the same. I thought there would be something more, but it's the same idea. So the problem is with a binary. I know it's always going to be the problem. The binary search is always going to be the problem. I am pretty sure that this is correct. Yeah, it is correct because I have passed. I think this one passed more than half of the test cases. So the reason, we passed 49 out of 55, right? So I don't oh geez, oh my god, my goodness, is there even a 1? There is a 1. So what did I return? Output -1. Expected is 2. I can wait for 2 minutes. Yeah, the problem is with the binary search. I'm not good with this. If there's no file, return this, that's fine. And then that's this, and then we basically just move around, and then try to get the new states. This is like 0 minutes, 1 minute, 2 minutes, all the way down. And then we have the length. That's the total number of minutes we can wait, right? And then we say maybe the load shall be, I don't know. So for each one, we start from here, right? And then we try to go. We say we'll go right or go down. Yeah, this just means they arrive at the same time. Or this is in, or this is not in. Which means low is much smaller than 0 and then return. Do you want to debug this? My God. How are we supposed to debug this thing? I don't even know. Try just say low, high, and then mid. So low, high with a 1, and it tells me 1 doesn't work, right? It tells me 1 does not work, and then it dropped down to -1. but the answer is 2, which says you can wait for 2 minutes. So I think there is big issue here. Big issue. Okay? Big issue. Maybe, I don't know. Q is the initial start. Okay? And then with every single file, we want to go around. Okay? And if it's not in the previous, because if it's in the previous, the ideal is if it's in the previous, then it must have been considered already. It has to, we want to go expand to new things, right? Expand to new things. So we only get a new ones, right? And they get new ones because the previous ones already expanded. Let's see, what does this one tell us? Let's see, what's F? Aye. So 0 minute. So there are 2 ones. There are 2 ones. So 0 minute, 1 minute, 2 minutes. So I should have 1, 2, 3, 4, 5, 6, 7. I should have 7. 1, 2, 3, 4, 5, 6, 7. That is correct. I have 7. So now the question is, from 2 minutes to 3 minutes. So if we say the tick, right, is the waiting, the amount of time you can wait. So wait 0, wait 1 minute, and then it should be this state. Wait 2 minutes, should be in this state, right? So if we say wait mid number of minutes, so we'll wait for that. Already, we wait for that, and then we say now we start going. Okay, now we start going. So go on this to the next state, right? From whatever there, we go to the next state. And when we go to the next state, right? When we go to the next state, that's like another minute has passed. So here, the tick, we start with +1, right? Because that's the next tick, right? The next tick. So it's the next state. Oh, hold on. Let's read the question one more time. If the file spreads to the safe house immediately after you have reached it, it will be counted as safely reaching the subs. But how about, like, oh no, it doesn't work. The safe house is the only way. That's like the next step is the safe house, and the next step is also the fire state. Then we're fine. We're okay. It just says if the previous, the tick -1, which is the previous state, if the previous state, it has not reached there, so the next state it will reach or it doesn't reach, it doesn't matter. They're all good. And this just say the next one will not go to the fire state, will not be there. Don't know why it doesn't work. Yeah, this is not working. Might as well print this out. So wait for 54 and go 0, 0. Okay? 0, 0, I can only go to 0, 1. And from 0, 1, I can go to these two. 1, 1. And the probably file already spread here. Now we're gone. Alright, so the question is I wait for, that's mid. Mid is 1. Okay? So I wait for 1 minute. And then go. Wait for 1 minute. I go to 7, 9. If I can visualize this, I guess the only way to debug is to visualize this bad boy. Wait, hold on. 7, 9? 1, 2, 3, 4, 5, 6, 7. How'd you get a 9? Oh. 2, 3, 4, 5, 6, 7, 8, 9. Oh, damn. Wait, hold on. What the hell? This is a dead end. It's not because of fire. Hold on. Start from 0, 0. You know what? I need to put this in a better place. Okay. Then let's say all of these. Okay. And we remove these. Hopefully we can have enough length. Yes. Okay. So we start from 0, 0. All right. Let's say. Okay. Then we go to 0, 1. Yep, that's the only way we can go. And from 0, 1, we can go to 1, 1. Yeah, I don't think the other can even hit here, or this. Alright, 1, 1, 0, 2. And from 0, 2, from 1, 1, we can only go to, alright, well, 0, 3. Okay. And from here, we can only go to 2, 1. And from 2, 1. Right? So 0, 3, 2, 1. And we have a problem here. Oh. Why are you limiting yourself, man? Why are you limiting yourself? Why? Hold on, I need to let my cat out. Seriously, man. Why do you limit yourself? I don't know, man. It was correct. It was correct. So we shall allow it to go. But then we run the risk of going backwards, right? So we need, oh Lord. So the ones we visit, we should not visit again. Okay, we do have to. Okay, that's just the traditional one. So visited. Okay, so that's that. And this is gonna be not gonna be a set. It's gonna be this. If this, right? And NINJ not in visited. Then we check. Then temp.append and then visited.add in visited Okay. Well, it turns out by limiting ourselves, we have passed a lot of cases. Man, if this one passes, I'm gonna be so mad. Boy, it passed all the other test cases so far. All right. We're no longer limiting ourselves. We'll go 4 directions. What if it times out? That will be very tragic. Come on. Edge cases. This must be edge cases. This must be edge cases. We hit. Should be -1. Yeah, there is no fire. Oh, shoot. There's no fire and you cannot reach. Oh my god. No, we have gone further. I think this one's further down. My god. Alright, so without fire, right? Without fire, then this cannot be, right? If it has fire, then we do this. If it doesn't have fire, so okay, let's do this. Let's say if fire states, it has to have something in order for this one to work. Okay, so if there's no fire, we shouldn't go here. That's going to be 0, right? 0, 1, 2, 3, 4. So we're gonna have to rethink this. This is -1, so we don't have a fire. So we don't have fire, we can wait. So len is 0, right? If len is 0, and then mid immediately is smaller than 0. Okay, so if len is 0, no fire, but we can reach, right? We can reach. What if we do this? -1, -1, okay? So in this case, we always have fire. Don't need this one. Right, and then we don't need this one. We always do this. So fire always have something, right? It always has something. Tuples, no add. Set. If you always add something inside. Doesn't feel right. How do we handle this? What if with low we just set to 0? What's going to happen? Then this. And this is 0, so it just immediately come out. That's not right, right? That's not right. We should say if file state, if we have nothing in it, we just put a dummy in it. Okay, we put a dummy in it, and then basically we see if it can reach. If it cannot reach, right? So tick gonna start from 0. Right, now we say for 1, and then it's not in, so we're gonna keep adding, right? We'll keep adding. Eventually, if it reaches, then we're good. And low would be mid plus 1, and then 1. And come out as 0. Well, let's go say plus 1. Okay. And then, yeah, we have this, which is fine. And then we just say what? If not fire states, right? Or this, or this. Oh. How did the last thing still not right? I shouldn't be able to reach. Yeah, middle should be 0. Never be 0 here. Low, high, mid. Yeah, 0, 1 is 0. And then we try to go nowhere to go. So Q empty. It's not come out, so we didn't find it. So high equals mid. So high becomes 0. So come out low is 0. Right? Low is 0. And I say 0 smaller than. So we return this. Okay, so what we have, dang it. Maybe we need to expand it to -1. I don't know, just, okay, -1 works. Well, it seems like -1 all works, huh? Ooh, -1 works, so I'll expand a higher, I expand a lower, a little bit lower. Trial and error. Lord. Okay, let's try this one. That was correct. Ooh, it's huge. Oh wow, 52. Damn. 53. Alright, so we just need to make it more efficient. How? Okay, what we can do is instead of saving all of them, we're going to save the new ones. And then as we go through, every tick of the minute, we just, okay, because we have a memory issue, so we're trying to save the memory, which means in here, it doesn't affect. Oh, it does affect. Visited. What is the same thing? Visited is equal to fire states 0. Copy. I think we have copy for this. We can copy it. Okay. And then if and not in visited. Okay, if it's not in visited, temp.add visited.add j. And here goes temp and file states.append just the queue. Okay, just the queue. Now this will be all wrong, which is fine. Just we're gonna just append the queue, which is the front, right? The current front. Because every time we pick the front out. Okay, so everything else stays the same, but whenever we do here, let's say condition 1 is len fire states is equal to 0. Okay, that's condition 1. Oh, we have this. We have this. We say len fire states equal to 0. That's the first condition. Second condition is, let's try this. not in the previous. So and say for k in range from 0 to minimum this. Okay. No, it's actually this thing. So for k in range from 0 to, actually we need to go +1. And what we want is file states k. We say ni, nj, not in, right? It's not in. Because if it's inside, that means it cannot do. So we want them to be all not in. Right, we say, so that's condition 2, all. So anyone is not in is true, true, true. Any false, which means in, that go resolve into false. And then condition 3 equal to same thing, all in shall be ni equal to n minus 1, nj equal to n minus 1. This and this, this and this, and all of what? All of n minus 1, n minus 1. Right? Not in file states k. K in range 0 to minimum, tick in len file states. Right? It's the same thing. And then it cannot be in. Right? So that's the third condition. So with all these conditions, we can say if condition 1 or condition 2 or condition 3. Right? If we have any condition is true, then we do this. So let's test this. Oh God. Oof. Gaudy monstrosity. Ooh. 4 milliseconds. Oh my God. Come on. Come on. Just pass. Just pass. Oh. Okay. We need a new method. We need a new method. Oh, lordy. That is actually a good idea. That is actually a good idea. So I'm going to change the grid. So instead of having fire at a 1, right, what I'm going to do is turn those into 0. Means a 0 minute. 0 minute have those. And then 1 minute, there'll be 1. 2 minutes will be 2. So I change the grid value to 0, 1, 2, 3, all the way to however many. And then, from my point of view, they're going to go out, right? And then, so I just need to check this cell. If the cell value is larger than the current tick, right? Which means I arrive here before the fire does, then I'm good to go. Okay, in that case, I need to make some changes, make some serious changes. So everybody, because I say if I arrive at here and I'm smaller, right? If I am smaller than the current value there, that means I can go, right? That means I can go. Yeah, if I'm smaller, that means I can go. If I am bigger, that means it has, so we're gonna change. Okay, serious change. So what we're gonna do is all the 2 are gonna become negative value. And my value is gonna be, it's gonna be tick, right? I just go every place and I have my tick. If this value is smaller than my tick is just like how many times it's passed, right? If it's smaller than my tick, that means I cannot be there because it's already been occupied. So if it's smaller than my tick, but if my tick is smaller, then I can go. So every place is going to be positive infinity. Okay, every place can be positive infinity, and the stone is going to be -1. Okay, and the fire is going to be 0. All right, initial fire is going to be 0. And then as I expand, right, okay, so let's make this change. We are going to conquer this ridiculous thing. So we're gonna, this is the first initial change, right? So here's what we're gonna do. We say if grid ij is equal to 0. Okay, if it's 0, then grid ij can equal to math.inf. And then we say elif is equal to 1, that means it's a fire. Right? If it's equal to 1, it means it's fire. And because I hit it first, I can change it, it won't hit again. Then we simply say that's the 0 minute, right? And we say grid ij equal to 0. Okay. Else grid ij equal to, so if it's not 0, it's not just 2, it would be -1. Okay, so we don't need any of these. Okay, so that's that. And after we've done that, we need the initial state. Come on, we still need a queue. Okay, we need a queue. So we need a initial q equals be this. Right, q gonna be this, and then if this, we're gonna say q dot append ij. Okay, so coming here, we say if q, right? If q, oh, we can just go while q, right? Interesting idea. So we can just say visited.add ij, right? And then I don't need any of this. And then look at that. So it's a while q. Temp is going to be this. So then we do blah 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 blah, and then we say if this, because we just expand, right? We need to say if this, and this is larger than 0. Okay. So we say this is equal to infinity. Yeah, we have to go this way. If it's equal to infinity, which means, if it's equal to infinity, then we don't even need visited, right? If you think about it, we don't need the visited because everything is infinity. And if I visited, it's not going to be infinity. So this is going to be append, right? And after the append, this is going to be grid ni nj equals what? Equals grid ij, right? If you think about it, it's grid ij plus 1, because we did one tick, right? We did a one tick. And then q equal this, we don't need this. So we don't need this. We have a q, but we don't need a visited. Interesting. Very interesting. So when the time we're done, we have everybody populated with something else. Okay. And then we're gonna binary search. What do we know about the largest value? I don't know the largest value. Well, the last n9nj, right? The last n9nj. So let's call this fire. Max fire tick. Max fire tick shall equal to grid n9nj. Oh, what if we never? Good point. Good point. So this one, let's put it here. Max fire tick shall equal to 0 at this time. and this is all 0, right? And then and then 23. No. So we go for this, blah blah blah, 27. Then we just say max file tick equals max file tick grid ni and j, right? So blah blah blah. We don't have to do this, and we say it's a max file tick +1, and then we try to do this. This is the same thing. It's a queue I visited, and I have a tick, which is the current tick. Okay, which is current tick. Mid is the number of time you have to wait, and then we do current tick, and then we say blah 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 blah. If this and what? So we're looking at ni and j. We're looking at this position, right? And I say if it's smaller, if my tick is smaller than this value, right, which means fire has not reached here yet, then good to go. Okay, then we're good to go. Or if it's the same, but then we're good to go. So in this case, what we're gonna do is we're gonna find here, and then change to a. So we're gonna change all this. We're gonna say if this, and the tick is smaller. Hold on. So this is the hard requirement, right? It's not visited before. And then I'm gonna say if tick is smaller than grid ni and j, right? The current tick, this is the one we want to go to, which means we can reach there before the fire does. So if it's smaller, or, right, we say or, which means it's equal to, or tick is equal to grid ni and j, and ni equal to n-1 and j equal to n-1. So under this situation, and of course if there's no fire, right? I should probably do this at the start. If max fire tick is equal to 0, or, so we have 3 conditions, okay? So we don't need all these. So if we have these 3 conditions, then we can keep going. And then tick +1, blah, blah, blah. All right, let's see. And we have this, it's not defined, that should be max fire tick. Okay, we still have the last one. Come on, man. Come on. What is it? So no fire, so fire is 0, okay? So -1 and 1. minus 1 and 1. Mid is 0, right? Mid is 0. Okay, so mid is 0, then it doesn't work, right? It doesn't work. So high is going to be 0. Continue. Come out is 0. How did it pass the last time? Wait, hold on. Low is minus 1, so 0 doesn't work. High equals 0. And then we'll go back. I don't know what you're doing, man. What? Yeah, high equals mid. Mid is 0, right? Wait, what the hell? What? How'd you go to 0, 1 or 1, 0? Because max fire take as 0 goes first. Okay, I'm going to change order. Oh, I can just do it this way. And grid in J is larger equal to 0. It's an and. Yeah, it's like what the heck? Trying to save a few strokes. Alright, let's try this one. Alright, let's see if it's any faster. I think it is because we don't have to prepare. Oh, this is the thing. This is the thing. Come on. Oh, God. Wow. Wow. How long are we spending on this? 1 hour. Damn. Damn. Oh, Lord. Oh, Lord. Oh, Lord. BFS. Yeah, it is BFS. Inf 0. Oh, war is fire. War is fire. Bisect. What? Oh, you can use the key. You can use key. That's the comparison, right? Alright. Honestly, I don't want to try to figure out some other things, but how about, let's say, we save this for tomorrow. But we did pass it, so our idea was correct. It was the correct idea, so kudos to myself. The implementation requires a lot of change, and we start from a very unfriendly one, memory overload, and then time overload. So finally, we did figure this one out ourselves, which is, I think it's pretty nice. I think it's pretty nice. Yeah, it's really, really nice. It worked. It worked. 2 levels of BFS. The binary search does take some time. Oh, wow. What a problem. So we had the correct idea from yesterday. What is yesterday? Yesterday is 30. In fact, our idea was exactly the same as the hints, but our initial implementation was not correct, and actually we had a little bit trial and error to find the low and high. Right, we have a bit trial and error. The high is actually we understand. Low, I guess we can actually set low to any value. It will work. Yeah, set it to any value. It will work. Just set it to a negative value. It will work. And we can actually do, let's say, 100. We can say this one too. I don't know. On this, it will still work. All right. Maybe that's actually better. So this is the key. So set low and high to some very small and very large value. So this guarantees, right? This can guarantees that if it is not possible to reach the destination, low will always end up negative, and if it is always possible to reach, then high will always be larger, will always not be smaller than max fire tick. In fact, I think it's m times n will be sufficient. And of course here we can just go y minus 2. Some negative value, right? Some negative value. Was not optimal. We try to create a set of points, a set of coordinates of fire at I minutes, after I minutes wait, after I minutes of wait. For each minute. This led to memory limit exceed. We then tried to only record, right, the what's it called, the front. I was gonna say front end, no, the front, yeah, the front line of fire. I'm going to record the front line of fire and iterate through all the fires over the waited minutes, and that caused TLE. Eventually, I was able to use to modify grid and put and use number to record when fire has reached a cell. For instance, if grid I j equals 3, that means after waiting, right, for 3 minutes, grid ij has turned into fire. This setup is both memory and time efficient. The rest is just 2 rounds of BFS, one for fire and the other for finding the path from source to destination. And we need to use binary search to approach the maximum amount of waiting time. I don't even know what's the runtime. OMN is definitely needed to do this. And for this thing, log I don't know, OMM, I'll call OMM log MN. We'll read this tomorrow. I guarantee you, we will read this tomorrow. I don't want to deal with this anymore. I'm tired and I just want to end this thing. We did actually pretty well. Okay, that will be it. That will be it. I will see you guys tomorrow. Adios.